All right, so now let's go back and look at solving these, finding the area of a regular polygon using special right triangles. Honeycomb is made up of regular hexagonal cells. The length of a side of a cell is 3 millimeters. What is the area of the cell? Now the directions don't say this, but in several of your problems you're going to run across, it's going to ask you to leave it in simplest radical form or an exact radical form. And sometimes it'll say round to the nearest whole number or decimal. So I'm going to show you how to do both ways. So the first thing we're going to do is we're going to write down all of our abbreviations, which is NSPACHA, N, S, P, C, H, and A. Now, the number of sides in this is going to be 6. The side length they give us is 3. So 6 times 3 is going to give us 18. So we've got part of this. Now, if you look at this picture here, all we know is that this is 3, each side is 3, and that this, our apothem, is not given to us. So I'm going to draw the apothem here. Draw it straight down to the side. So that means that this is a right angle. Now, next thing I want to do is I want to draw kind of part of this. I'm not going to, and this is what I would draw if I was working this problem and that there was no picture given to me. I only really need one triangle, but I'm going to draw 2 here to kind of help set it up. So the black dot is our center. So anytime we're having something missing, we don't have the apothem, this is the apothem, we're going to have to use our central angle and half angle. So to remember, we take 360 divided by the number of sides, which in this case is 6. This gives us 60 degrees, which means my central angle right here is 60 degrees. Now the half angle is going to be half of 60, so 60 divided by 2 is 30, which means my half angle here, and I can write it here, is going to be 30 degrees. My third angle, which I don't have to write down here, but just know that this is the 30, this is right angle, so this becomes a 30, 60, 90 right triangle. So to remember what our 30, 60, 90 right triangle is, we have this side is in, this is our 30 degree angle. So our short leg is always across from the smallest angle. This is 60. There's our right angle. So we have in, that means the hypotenuse, as we've discovered, is 2n, double it. This is going to be the n value times radical 3. So we have this right triangle right here. Now this distance is 3, which means this distance right here is 3. But this distance is, because this apothem cuts this triangle in half, this is going to be half of that distance. Now, if the problem was just leave it in terms of a decimal, you could write this as 3 divided by 2, which is 1.5. But because they want it as an exact number, or because I'm asking you to do it, you're going to write, instead of this being 1.5, we're going to write it as 3 halves, because that's what we're doing. 3 divided by 2 is the same thing as 1.5. So instead of putting the decimal form, I want the fraction form, which is 3 halves. So if it's odd, you'll have a fraction. If it's an even number, side length, you'll divide it by 2, and that will give you that whole number. So if that means that this part right here is my 3 radical 2, which means that this side is going to be whatever the n is times radical 3. So this is going to be 3 radical 3 over 2. So that means my apothem here is 3 radical 3 over 2. So we have now our apothem, we have our perimeter. We can now solve for the area of this hexagon. So area equal to 1/2. Now this is a fraction, so I'm going to make 18 a fraction. So 18 over 1 times 3 radical 3 over 2. So we can simplify this as we go. 2 goes into 18 9 times. 9 cannot go into 2 can't go into 9. It can also not go into 3. So we multiply 9 times 3 and get 27. Bring down the radical 3. And we have 1 on the bottom, we have 1 and 2. So this means 1 times 1 times 2 is going to be 2. Because 2 does not go into 27 evenly, then this becomes our answer. So this is going to be millimeters, which means it's millimeters squared. So our answer to this problem is 27 radical 3 over 2. Now for the decimal form, get our calculator out, and we can pick 27 square root of 3. Okay. It gives me this answer, and I'm going to divide it by 2. That gives me an answer of about 23.3, which means that if we're going to now divide it by 2, that gives us 11.69. And there's no reason to do it by 2 again. So the correct answer would be 23.3. So if we're going to round to the nearest whole number, it's going to be approximately 23 square millimeters. So we got 2 answers here, 23 square millimeters or 27 radical 3 over 2. So these two are both correct answers if they ask for it as an exact answer in terms of radicals using radicals as needed. This would be our answer. If it was just a whole number or any decimal, we'd round it off and this would be our answer. So now I want you guys to take a look at our next one, part B. The side of a regular hexagon is 16 feet. What is the area of the hexagon? Round your answer to the nearest foot. So once again, not only I want you to put it to the nearest foot, but I also want you to put it as an exact answer using radicals as needed. So pause the video now and work this out. All right, so we have everything filled out. We have the number of sides is 6, side length is 16, perimeter becomes 6 times 16, which is 96. We didn't have the apothem, so we had to find it. So the first thing we do is find our central angle by doing 360 divided by 6, which is 60. Half angle would be 30. So this is a 60-degree angle here. Half of it is 30. So we're looking at our one right triangle. So in this case, this is 16. So because this is half of the side length, it's 8. Because it's even, we're going to go ahead and write the whole number 8. And then the apothem is, because it's across from the 60, is going to be the short leg, which is across from the 30, times radical 3. So we have apothem of 8 radical 3. Now, multiply it out. Area is equal to 1/2 96 times 8 radical 3. I put these over 1 so it's a fraction, but you can just take 96 times 8 divided by 2, and that number becomes 384 times radical 3. Now, the last part, we're going to calculate the decimal. So we'll take 384, and we're going to put it times radical 3. That answer comes out to be approximately 665 to the nearest foot. So 665 square feet. So we got both answers here. First answer is an exact answer, and the second one is rounded off answer to the nearest foot. All right, so let's take a look at the next one. Number 7. All right, once again, we have a regular polygon. This is a regular triangle, which means it's an equilateral triangle. All sides are the same, all angles are the same. So, begin this problem, we're going to start by writing our N, S, P, C, H, and A. Number of sides we said is 3. They didn't give us a side length. So this 18, and the way it was drawn here was bad. I want to put this 18 right here, which 18, this is the radius. Okay, radius is when it goes from the center to the vertice. So we don't have a side length, which means we can't calculate the perimeter. And we don't have the apothem. The apothem is going to go from here to here. So that's the apothem. And then if I continue this on, I could draw the rest of this triangle here. So this right here would give us our one triangle. I'm going to go ahead and draw this up here to help identify our central angle and half angle. So once again, the apothem is the blue line. So this is our right angle. So we start going to find our central angle. That's going to be 360 divided by the number of sides, which in this case is 3. So that's going to give us 120 degrees. So this angle right here is 120. This angle right here is 120. And this angle right here is also 120. So our half angle would be 120 divided by 2, which is going to give us 60. So we have a 60-degree angle here, which means this angle over here has to be 30. So once again, we have a 30, 60, 90, only this time it looks a little different. It's been drawn to the side. So if I was going to draw this, our special right triangle, and just flip it onto the side, nothing's changed in it, just the way it's oriented. So we have our right angle here, 60 degree here. This is still in, it's across from the 30. This is our hypotenuse, which is twice the short leg, which is 2 in. And this is our longer leg, which is across from the 60, and that's going to be in times radical 3. So if you look at this picture here, this is our 18 is what we have. That means that 18 has been multiplied by, that n has been multiplied by 2 to get 18. So if we divide by 2, that gives us that this should be 9. And therefore this side should be whatever this is, the n times radical 3. So this should be 9 radical 3. So if we go back over here to fill out our information, this is going to be our apothem, which is the same as this right here. So this is going to be a measure of 9. So the apothem is 9. Now, this side right here we said was 9 radical 3. Now remember, the apothem cuts this triangle into 2 congruent parts. So this is also 9 radical 3. And when you're adding this together, it's no different than saying adding together 9x plus 9x. That would give us 18x. So instead of this, we're going to put a radical in here, and the rule is you can only add like radicals. These are both radical 3, so 9 plus 9 is 18 radical 3. So that means my side length is going to be 18 radical 3. So I can plug that in here, and now I have enough to calculate my perimeter. Now remember, we do not multiply any numbers that are outside the radical times inside. It's always outside times outside, inside times inside. So 3 times 18 is going to be 54 radical 3. Now, we have everything we need, so we can calculate the area by doing 1/2 times the perimeter, which is 54 radical 3 over 1. And then we'll multiply it by an apothem of 9 over 1. Now you don't necessarily have to put everything over 1. You can just multiply it out. So 2 can go into 54 27 times, and then we're left with 27 times 9. And 27 times 9 is going to be 243. Bring down our radical 3. And so this is our answer, 243 radical 3. Now I want all of our answers in these practice problems to be written in simplest radical form as exact answers. So 243 radical 3, it will be our answer. All right, so let's go to the next one. In this problem here, we've been given something different. We've been given the apothem this time. So once again, we start off by doing N, S, P, C, H, and A. So also we're going to draw this right triangle. I didn't draw the other parts, and so we can hopefully kind of quit cluttering it and just remember what parts are what. Now this is the apothem, so we're going to write that down here, 4 radical 3. That's the first thing we've got. Number of sides, we count them up. We got 1, 2, 3, 4, 5, 6. We don't know the side length, therefore we don't know the perimeter, which means we have to do the central angle again. So 360 divided by 6 is going to be 60, and the half angle is going to be 30. So this angle here is 30, this angle here is 60. Now what they've given us is the apothem here, which is the same thing as the side across from the n radical 3. So you don't have to draw these every time, but if it helps you visualize what we're looking at, then by all means, go ahead and do it. So once again, this is a 60-degree angle, this is our 30, and you should have this special right triangle in your notes. This is going to be our n value, this is our 2n, and this is the n radical 3. So if we have 4 radical 3 as our apothem, which is going to correspond with this part, so we can say that n radical 3 is equal to 4 radical 3. We want to solve for n, so we divide by radical 3. Cancels here, that means that n is equal to 4. So that means that this segment is 4. That's not our side length, that's just half of our side length, which means this side over here is also 4, which gives us a side length of 8. So our side length is 8, so now we can calculate the perimeter by doing 6 times 8, which gives us 48. Now, area is equal to 1/2 perimeter, 48, times apothem, 4 radical 3. So we can do half of 48, which is 24, and 24 times 4 is going to be 96. So 96 radical 3 is our answer. So remember, if they give you the apothem and it's got a radical in it, then all you're going to do is divide out that radical and whatever's left. So in this case it's 4, double it to get 8, because this whole side here should be 8, just like all the other sides. Calculate your perimeter, you get your apothem, multiply it out. All right, now this next problem, this is a unique problem because we don't have to set up and find the apothem. You can, but it will take you much longer. So if this, and several of these problems you're going to come across are figures where we know how to find the area other than using the 1/2 perimeter times apothem. So I want us to go back to the regular triangle formula, 1/2 base times height. Now if this is an equilateral triangle, it's a regular polygon, which means that all sides are the same. So this right down here is also 10, from here all the way to here. Now that would mean that we have a base of 10, and all I have to do is identify my height. The height is going to be our line that goes from the vertex perpendicular to opposite side, which is similar to what we did with our apothem. Okay, this would be the central angle, we'd have the apothem here. So this is the height, h. Now in an equilateral triangle, each angle is 60 degrees. Because we bisected this angle right here, it's no longer 60, each of these are going to be 30. So we have two 30, 60, 90 right triangles. Which means if this is going to cut it in half, that means that this segment right here is cut in half, which means this is 5. Which means the hypotenuse is double. This is 5, which means our apothem is going to be, or the height is 5 radical 3. So the height is 5 radical 3. So now 1/2 base 10 times the height of 5 radical 3. Half of 10 is 5, and 5 times 5 is 25 radical 3. Now you could have solved it the other way, it just would have been a whole lot harder. So remember, unless they give you the radius for a triangle, you can use the regular 1/2 base times height equation to help find the area. Now if they give you the apothem, then you'll have to use the 1/2 perimeter times apothem. But it's all based on what they give you. All right, so let's go look at number 10 now. 10 is a square. This is a unique polygon because there's actually several ways we can calculate it. We can go back to what we learned first about a square, which is 1/2. Well, excuse me, we'll come to that in a second. We have side squared. It's also a rectangle, which means it's base times height. And then the last one, because a square is also a rhombus, we can use the rhombus formula. So 1/2 diagonal 1 times diagonal 2. And last would be the 1/2 apothem times the perimeter. So in this case, the one we're going to use is we're going to try to use this diagonal, because a square is also a rhombus. Then we can calculate our full diagonal, because in a rhombus the diagonals bisect each other, and in a square your diagonals are congruent, like a rectangle. That means that if this length from here to here is 28, then this is 28. So what they've done is they've given us a radius. So we can complete our full diagonal, which makes this distance equal to 28 plus 28, which is 56. And because our diagonals are congruent, this is also 28 here. So diagonal 1 would equal to 28 plus 28, which equals 56. And that means that diagonal 2 would be the same, 56. So area is equal to 1/2 56 times 56. And so that's going to give us 1,568 is our answer. So another ways I've seen it given is I've seen them give you a line down here. Draw this one in red. So I've seen them give you the apothem before. If they give you the apothem, let's say our apothem is 14. If the apothem is 14, this goes to the center, which means this side over here would also be the distance of the apothem, which would be 14. So 14 and 14 would give us 28. That would mean my full side length would be 28, and this side over here would be 28. So you could use the formula where you have the side squared or base times height. So 28 times 28 would give us the area for our polygon, the same as we did here. Okay, we get two different answers because we have different diagonals, but this is one way they may give it to you. All right, so let's take a look at the last one. In this problem here, we have a hexagon. So I'm going to draw the apothem. We're going to write out N, S, P, C, H, and A. Number of sides, once again, is 6. Side length we don't have. Perimeter we don't have. The apothem we don't have, because they gave us the radius. So central angle is going to be 360 divided by 6, which is 60, and our half angle would then be 30, which means this is our half angle of 30. This is going to be our third angle of 60, and there's our right angle. So now they've given us, this side is 8. 8 is the radius. So in our special right triangle, this is equal to the 2n. If you look at your special right triangle we wrote down earlier, divide by 2, it means n is equal to 4. So that means that this is our short leg, which is 4, which means our apothem is going to be 4 radical 3. So, as you'll notice, this problem is similar to the problem we worked earlier, where we get the side length now is going to be 4 here, which is going to give us a side length of 8, which is also the same as the radius. And the reason why is because in a hexagon, and this is the only one this works for, the hexagon, each triangle is broken up into 6 equilateral triangles. These are 60-degree angles. The central angle is 60 degrees, so we have an equilateral triangle, which means if this is 8, then this is 8, and this is 8 over here. So they're all 8 going around the radius. Your base is also 8 as well. So that's another way you can look at this and solve. But, and that'll be useful for other problems as well. So the side length here is going to be 8. Perimeter 48. Apothem is going to be 4 radical 3. So 1/2 48 times 4 radical 3. Once again, there's only one radical, so radical 3 will be in our answer. And we'll take half of 4 times 48, which is going to give us 96 radical 3. All right, so this concludes our lesson 10.3, finding the area of regular polygons. So try your homework. Remember, write out NSPCHA. Fill in all the parts that you have. If you're missing any values like the side or the apothem, you have to find the central angle and the half angle. Set up your right triangle, find the missing side links. That concludes our video.